Hi, hello, vanakkam and welcome. This is your the First Step Academy Learn and Grow Educational Medium. Today in this video, we are going to discuss the answer for the book back problem number 8 in Unit 6 Optics. Let's go to the video. First, we'll read the problem. In Young's double slit experiment, the slits are 2 millimeter apart and are illuminated with a mixture of two wavelength lambda naught is equal to 750 nanometer and lambda is equal to 900 nanometer. What is the minimum distance from the common central bright fringe on a screen 2 meter from the slits where a bright fringe from one interference pattern coincide with the bright fringe from the other? This is the question. So ultimately we need to find what is the minimum distance from the common central bright fringe on a screen distance of 2 meter. So now as usual we'll take the given values from the problem. Given values are the slit distance small d. They have given the value is 2 millimeter, where we can write in terms of meter as 2 into 10 power minus 3 meter. Now the wavelength, two wavelengths they have given. One is called lambda naught, another one is called lambda, where lambda naught is 750 nanometer, where in terms of meter 750 into 10 power minus 9 meter, where lambda is 900 nanometer, where in terms of meter is 900 into 10 power minus 9 meter. And also the distance between the slit and screen, capital D, they have given as 2 meter. Right? So this is the question. Now the condition for the bright fringe or the maxima in Young's double slit experiment is y is equal to n lambda capital D divided by small d, where here y is the distance, where n is the order of diffraction, where lambda is the wavelength of source or wavelength of light, and capital D is the distance between the slit and screen, and small d is the slit distance. Now this equation can be written based on the two wavelengths called lambda naught and lambda. For lambda naught, this equation will become as y is equal to n1 lambda naught capital D divided by small d, where that I have taken as equation 1. For lambda, y is equal to n2 lambda capital D divided by d, where that I have taken as equation 2. Look at this problem. There is a statement called a bright fringe from one interference pattern coincides with a bright fringe from other. So there are the two wavelengths. Bright fringe from one wavelength is coincide with the bright fringe from the second wavelength, right? So with this statement we can consider that equation 1 is equal to the equation 2. So the distance for the lambda naught is equal to the distance for the lambda. Hence equation 1 and 2 equal, so we can write it as n1 lambda naught capital D divided by small d, which is equal to n2 lambda capital D divided by small d. Now this d, small d, and this capital D and small d will cancel. We will get the value as n1 lambda naught is equal to n2 lambda. Now n1 by n2 is equal to lambda divided by lambda naught. Now substitute the given values in this equation. Now n1 by n2 is equal to 900 by 750, where when we cancel with a common term, common factor, we'll get n1 by n2 as 6 by 5. Now the value of n1 by n2 is 6 by 5, that we got it. Now it means that n1 is 6 where n2 is 5. That's exactly the meaning. Now by substituting any one this value in any one of the equation called 1 or 2, we can get the minimum distance. So now the minimum distance can be calculated by y is equal to n1 lambda naught capital D divided by small d. Now the given values can be substituted in this equation as y is equal to n1. n1 is 6, right? 6 into 750 into 10 power minus 9 into 2 into meter divided by 2 into 10 power minus 3 meter. By solving this equation, we'll get the value as 4500 into 10 power minus 6 meter. Further, this will be converted into the millimeter as y is equal to 4.5 into 10 power minus 3 meter. So the minimum distance that what we found is 4.5 millimeter. Previously what we got, y is equal to 4.5 into 10 power minus 3 meter, where when we convert to the millimeter, we got the value as 4.5 millimeter. So the minimum distance from the common central bright fringe for the bright fringe, what we calculated is 4.5 millimeter. Hope you understand how we arrived the answer for this question. If you like this video, kindly share it, comment it. Also subscribe to our channel. Thank you for watching. This is your the First Step Academy Learn and Grow Educational Media.